have that in by what time today? 4 o'clock. And then anything that you have out 7-1 or 7-2, 7-1, 7-2 stuff that you got on Friday, make sure you have that in by the end of the day today as well. All right. Also encourage you to check out JMC, find out where you're at. And we're about midterm right now, so about 6 more weeks. And let's see, if today's midterm, that means the school year's half over already. It's gone quickly, hasn't it? Oh, very quickly. Half over already. Which means you guys only have a trimester and a half to put up with me, and then you're onward and upward to better math classes, right?
No.
Right? Okay. All right, well, let's get rolling here today, guys. 7.3 is titled Shapes of Distributions. And what we need to try and answer today is how can you use a histogram to characterize the basic shape of a distribution? So, in order to be able to do that today, we're looking at describing the shapes of data distributions. We're going to use those shapes of data distributions to choose appropriate measures. And then we're also going to compare some data distributions. How many of you guys have heard of a histogram before? You may have heard that word before. Remember what it is, Carson? Okay. How about a definition? Any chance you know a definition of a histogram?
A graph that displays data in intervals.
That's an excellent description. Very good. Yeah, it is a bar graph that displays data in intervals. I'll show you what it looks like here. Basically, here's some examples of histograms right here. But when I say it shows data in intervals, let me ask this question. If I had to ask a question, how many people in this room are between 0 and 9 years of age? How many people would raise their hand? How many people would raise their hand? Not act like, but actual age, Carson. Okay. All right. If I said this question, how many people in this room would raise their hand if their age is from 10 to 19? How many hands would go up? Everybody except for what? 2. All right. Now, I'm not going to bait you into this, Mrs. Olson. Okay, so you can refrain. How many are going to choose from 20 to 29?
10. Wait, no.
Thank you, Terry. Give her an extra credit there. All right. All right. No. What I would say, you wouldn't have any there. 30 to 39. I'm not going in that range, but 40 to 49. Where am I going? I'm going in the 40 to 49 category, okay? So if you can kind of think of a bar graph saying what number of people lie in that interval, that's what's going on here. So it's just like saying, hey, here's an interval of people right here. If this is like 10 to 19, how many are in the 10 to 19? That's how high that bar is. That represents the number of people that fall within that interval. So bar graph that shows data in intervals, all right? And then also the other one that we're going to talk about today is frequency table. And a frequency table is simply a table that's going to show the amount of numbers within a certain interval. All right, it's going to show how many people are within that age range of 10 to 19. In this group, how many people are there? 7, 11, 12, 13, 14, 15, 16, 17, 18. There's 19 of you. So on that frequency table, if I said how many people are between the ages of 10 and 19, you would put the number 19 next to it. There's 19 of you that are in there. Okay. All right, guys, examples of distributions then when we start looking at histograms right here. Some general shapes. You guys have all seen bar graphs like this. What type of graph is this right here? What's it say? Skewed left. It looks like the left's tail here is a little bit longer than the right tail. If you can imagine yourself drawing an arc like this, that would be kind of like that. Which tail here looks like it's a lot longer, the one on the left or the one on the right? The one on the left, right? So it looks like it's being pulled to the left here. Yeah, can you identify it then as something that's skewed to the right shape-wise? You okay with that? And then this graph is considered basically a centered graph, or what's the word they're going to use for that shape? Looks like the left half kind of mirrors the right half. So anytime you got the left half, now it doesn't have to be an exact mirror, but as long as it looks like it's pretty close to the left half mirroring the right half, that would be considered symmetric. All right. So make sure you refer to these here in terms of shapes. Again, you've seen stuff like this before, right? Okay. We're just going to start tying some terminology to this and rolling with it. All right, page 2 here then. How about a volunteer to read example 1 where it says describing the shape of a distribution? How about a volunteer to read that for me? Volunteer to read example 1 for me. Thanks, Taryn.
The frequency table shows the number of hours that students in your grade spent on homework last week. Display the data in a histogram. Describe the shape of it.
Okay, so a number of hours that students spent on homework last week. All right. How many people spent between 0 and 1 hour? 5. How about between 2 and 3 hours? 25. Okay. Our job is to make a histogram of this. So what I'm going to do is this. I'm going to put the number of hours down here on the bottom. You want to do the same. And then I'm just going to go ahead and for each interval right here, or each certain column, if you will, I'm just going to go ahead and put the number of hours down here. So this column is going to represent 0 to 1 hours. This will be 2 to 3. This will be 4 to 5. This will be 6 to 7. This will be 8 to 9. This will be 10 to 11. And this will be 12 to 13. Okay. And then on the left side, I'm going to go ahead and put the number of kids that spent that amount of time. And I'm going to go ahead and count each row by 5s here. So I've got 5, 10, 15, 20, 25. All right, so how many were there in that first interval, guys? How many in that first interval? 5 of them. So all you're going to do is you're going to draw this up here to 5. Okay, there's that first bar. How about the second one, guys and gals? 2 to 3 hours. How far up am I going? How many? All right, 25. So this column right here, there were 25 kids that worked 2 to 3 hours of homework last week. Okay. How many were in the 4 to 5 range? 20. So 20 is right here. Here's that bar. How about 6 to 7? 18. So here's 15, here's 20. So I'm somewhere between 15 and 20, maybe right about here. 8 and 9 would be 12 of them, wouldn't it? So here's 5, here's 10, 12 might be right about here. 10 and 11 looks like it's right at 6. And then finally 12 and 13 is right at 2. So guys, which side of the, first of all, does that look like a symmetric graph? Does that look like the left half and the right half are kind of equal? Does it look symmetric to you at all? No. Does it look like it's skewed one direction? What direction maybe? Skewed to the right. So after I've graphed this, it says display the data in a histogram. We just did that right there. So what kind of a shape do I have? Do I have skewed left, skewed right, or symmetric right here? What do we have here? Skewed to the right. Very good. Yeah, it looks like the tail on the right is a lot longer than the left. So this is going to be something that would be skewed to the right. Okay. Whoops, I don't know what happened there. Let's try it again. All right, so show of hands right now. Who's on board with me right now so far? Pretty okay with this? Taking a frequency table, turning it into a histogram, identifying a shape, that should be pretty manageable, I think. Okay? That should be pretty manageable, all right? Okay, then. Questions about example 1 before we jump into number 2? Everybody have what they need there so far? Good? Okay. All right. Example 2 then, guys. Choosing an appropriate measure right here. It says a grocery store cashes checks for customers, and the amounts cashed for 1 week are in a table shown below. Okay, a lot of different values. And it says use display the data in a histogram using 6 different intervals. So, we gotta think about this one. 1, 2, 3. There's a line right in the middle here for you guys, right? I, for the life of me, cannot figure out why when I make graphs like this, it kicks the middle line out all the time, doesn't it? Don't know why it does that. So I'm gonna put that line in there like so, and guys, I'm gonna put my values down here for the histogram. I'm gonna go 0 to $25 here. We'll go 26 to 50. I'll go 51 to 75. $76 to 100. 101 to 125. And finally, $126 to 150. Let's do that. Hopefully that fits everything. Should. What's the highest check in there that they cash out? Is it 140? So it looks like all my values will fit within that, right? Everybody okay with that? Okay. So I think the best way to do something like this is the following. I've got to figure out how many checks are between 0 and 25. I think it's just to our advantage to go ahead and cross off the values that you have here. So let's just do 0 to 25 together. I'm going to go through this whole chart and cross off the ones that are 0 to 25. So how many in this first column would I cross off? Just 10. Okay, we want to graph the number of checks that are being cashed here that range from 0 to $25. So 10, there's one of them. How about how many in this one would I cross off? How about 15? That would go, wouldn't it? 2, 3, and 4 of them. Is that right? How many in this column are 15 to 25, or 0 to 25, I'm sorry? None of them, right? And then how many over here are 0 to 25, kids? Just the 25. So how many total values do I have in that table? 5 of them? 1, 2, 3, 4. Yep, looks like 5 of them. So I'm going to go ahead and raise that up here to 5. Okay, so 5 bars up. I hope I'm doing this correctly. I don't think I am. Let me check. I think I'm going to back up on this, guys. If you made your line, I apologize here. I want to go by 2s here, I think. Better go by 2s. So if you made that box, go ahead and get rid of that, all right? How many were there again? 5. So I'm going to go by 2s here. So here's 2, here's 4. This would make this 5 right in the middle for that bar, like so. All right. So here's my question. On this frequency table right here, the dollar amount values that we have in this table right here, who would be willing to count the number of checks that were cashed between $26 and $50? Who would go through and do that one for me, this interval? All right, McKenna's got that. 51 to 75. Who would go through and count the number of checks between $51 and $75? Andrew, you want that one?
Sure.
Okay, go through and count the ones. Carson, you got 76 through 100. Jacob, will you do 101 to 125 for me? And then, let's see, 126 to 150. I'll do that one, all right? 126 to 150. I'll do that one. All right, I've got mine. 126 to 150 is 1 right here. Okay, when you've got your interval that I assigned you figured out, let me know. Okay, McKenna, which one did you have? 26 to 50. How many were in that 26 to 50 range? 10 of them? Okay. 5175. Who had that one for me? Okay. Just raise your hand when you have your interval done, okay?
Just count how many numbers.
How many numbers fall in that range? Yep. Jacob, which one was your interval?
101 to 125.
And how many checks were there? One of them, 101 to 125, was one. All right. Carson,
76 to 100.
and how much was that?
4.
4 of them?
Yeah.
So, let's see. Andrew, you have yours yet? 9 of them? Okay. So here's what we get for a graph right here. So a lot of counting going on there. You guys agree with that? How many numbers were between 0 and 25? How many were between 26 and 50? How many of those numbers fell between 51 and 75? We just want to know how frequently that number appears in that table. And we represent it in a histogram here, all right? So, that being said right here, guys, take a look at that graph. Skewed right, skewed left, or symmetric? Looks like it's skewed right again. Right side here from the high point pulls to the right. So let's go ahead. Do you guys have that graphed already? Anybody have that graph? Not yet? This is funny. My phone's been recording everything I've been saying and putting it in a text message. No, I didn't go. I'm glad. I would have probably kicked a.
You watched the Bengals game?
Would have probably kicked a ice block and broke my foot.
Probably the most.
All right.
Yeah.
So part B right here, guys. Which measures of center and variation best represent the data? Guys, this was skewed to the right. You guys agree with that? You guys agree that it was skewed to the right? Would you agree with that? Do I have them mixed up in order? I've got a wrong order in there. Okay. Go to, that was part A that we just did, right? Okay. Go to the page then after this. It says display the data in histogram using 6 intervals. Go to the page that has this part right here. Okay, this should be, there's a page that's just gets switched around there. Is that all that happened, it looks like? Okay, you might have to switch it around there, all right? So this one, it has the big graphs on it. Maybe pull that out, like, can I do it? Like that, just tear everything apart, and then put that here like so. Is that better? There we go. Good. I'll send a stapler around if you want to rip that out here quickly, guys. There you go.
Yes, ma'am.
So go ahead and get that quickly. Okay, guys, right here.
Oh my God.
It says, which measures of center and variation best represent the data in this? Now again, you said the shape of this was skewed to what direction? Skewed to the right. Now what I want to make sure you understand is this. Don't forget about the box and whisker plots that you talked about in the past, okay? Don't forget about the box and whisker plots that you talked about in the past. A box and whisker plot that was skewed to the right meant that the right or left whisker was longer. The right whisker, right? So this is what this question is really asking. This is what I want you to understand. They talk about what numbers best represent the middle of a data set, okay, or the center of measure. If something is skewed to the right, remember, box and whisker plot broke everything down into quartiles. The lowest quarter, the next quarter, the third quarter, and then the fourth quarter, okay? Which was a disaster yesterday in the new football game. But we won't talk about that.
Why, what happened, Carson?
Some guy missed a field goal of 27 yards. But that's okay. I already told you, I think, that when I die, I'm going to call the Minnesota Vikings and have them be my pallbearers so they can let me down one last time.
That was the funniest laugh.
Yeah. Yesterday was devastating for me.
Did you watch the whole game?
Hmm?
Did you watch the whole game?
Oh yeah, yeah. I had my Teddy Bridgewater shirt on and my hat on, and I was sitting in a chair, and then the next thing I know, after the field goal was missed, for some reason was on the floor, pounding the floor, saying, "Not again, not again." And then the Pukers won yesterday, so that added a little salt to the wound. Anyway, I thought it would be a good idea for me to do some mathematical therapy to try and
Oh, you're
cure my blues. All right. So it's skewed to the right here, guys. Here's the deal. Is this upper extreme going to be some kind of a number that measures the center if it's skewed right? It won't, will it? Really, the number that's right in the middle here for some kind of a box and whisker plot is what number, guys? What number is right in the middle all the time? It's median. So what's going to be our best measure of center, guys? What's the best measure of center going to be? Well, that's going to be the median. That's the number that's in the middle for us. Okay, then they also talk about what numbers are going to represent variation right here. Well, guys, anytime you have a frequency table like this, your best measure of variation typically is what we call in the last section we called it a 5-number summary, okay? These numbers right here kind of represent how much they vary. What would the lower extreme be? What would the quartile be? What would the median be? What would the upper quartile be? And what would the extreme be? So typically, guys, in this right here, when it says which measures of center are we talking about, which measures of center are going to work for these data tables, typically what number works the most? What number is always in the middle or the center? Median. And then the numbers that typically represent the variation within a frequency table or a histogram are going to be that 5-number summary. Yep, the 5-number summary tells you how much stuff varies. So in other words, what's the lower extreme? You would have to go through and find those. We're not going to be doing that so much in here. They just wanted to describe what would you use then to show variation within this set. And again, we said, hey, since the graph is skewed to the right, we know that histograms that are skewed might match up with, didn't we talk about skewed box and whisker plots here? We did, didn't we? Okay, so we can go ahead and represent variation of numbers in basically a box and whisker plot. All right. Guys, an upper extreme like this being way out here, this is kind of like an outlier value, isn't it? Doesn't that outlier kind of bring your total average up? It's just like saying you have a bunch of low scores, and then all of a sudden you have a really high score. What's that do to your overall average? Does that pull it up or pull it down? It pulls it up. It pulls it away from where you originally were at center-wise, okay? All right, so then the last question to this would be the following. It says the store charges a fee for cashing checks that are greater than $75. So any check that's over $75, the store says, you owe us $5 for us to cash it, or something like that. How would you interpret the results? Well, guys, go back to the results here. You don't have to flip over. I'll go back here. Guys, were there a lot of checks over $75 that were cashed or minimal amount? Let's see, anything over $75, there was, it's like 4, 1, and 1. So were there a lot of checks that were cashed over $75 or not? No. Okay. So what's going on here? Either, if I walked in there with a $1,000 check, they might say we could have your check if we cash it or something like that, which is, I know, bending the truth a little bit, but why such low numbers there for anything that's cashed out over $75? Why are those numbers so low? What do you think, Carson?
Because people didn't want to cash checks that high.
They don't want to cash checks that high, or maybe the fee was
Really high.
maybe the fee was ridiculous. Okay, like a missed 27-yard field goal to win the game. But I won't talk about that.
Are you a little mad?
I'm devastated today. I'm not gonna lie. All right, my heart's broken. Good thing I didn't go. I would probably cried icicles. Yeah, exactly. Either they don't want to cash a check that high because they're worried about it, or maybe the fee is just too high. Maybe that's the reason that we didn't see a lot of checks being cashed above that $75 value. So maybe the fee is just too high. Okay, so again, guys, what I'm really getting at is this: anytime you start talking about skewing histograms either left or right, there's a lot of connections to box and whisker plots being skewed left or right, talking about a measure of center and talking about a measure of variation. Okay, the measure of center, what's in the center of a box and whisker plot all the time? What value is always in the middle? What value is always in the middle of a box and whisker plot? What's always in the middle? Median. Okay, that's always going to be a measure of center for you. All right, and then maybe the fee is just too high. Now that talks about maybe the low values are being skewed right. So this would say, well, let's see the dollar amount of checks here. But then when we talk about variation, you know, we had a lot of checks towards the middle here being cashed, and then to the outside here, not so much. So I think if you can just say, hey, if something's skewed left or right with a histogram, automatically think about its variation as it relates to a box and whisker plot. Okay, stuff that we've looked at before. All right, so now that I've got your papers completely messed up in order, do you guys have the next one that looks like this? Is there a double bar graph on the next page? Is there like two graphs? Okay, you are going to have to tell me, let me get the lines in here first. Yeah. Somebody say.
No, I was asking questions.
Okay. Let me get these lines drawn here real quickly. Give me 1 second, kiddos. All right. Okay. Can I look at somebody's graph real quickly? Yeah, there's a vertical thing right here. 4, 2. Do I have the shape of the first one correct, guys? That's the first one, right?
Yep.
And my second one starts at. Just tell me the frequencies if you could real quickly. This one's 2 up, right?
I don't like the same. Yeah, no, they are pretty bad this year and last year.
How am I doing? All right, so there's that right there. Okay, I had to borrow that, sorry. Okay, so let's take a look at this right here. Guys, can you tell me, what are the ages down here that correspond to each other? What's this first interval? From age what to what?
1 to 15.
1 to 15, so it goes by 15, so this is 16 to 30?
Yep.
All right, let me get these in here. 31 to 45?
Yep.
46 to 60?
Yep.
61 to 75? And 76 to 90?
Yep.
Man, if I'm exercises between age 76 and 90, I'll be happy. By the way, did you hear about that lady that's, I think she's 90, oh, like 92 or 93 years old? She just ran a marathon, 26.2 miles. Did you guys hear that on the news at all this weekend?
My grandma can't even walk across her
I
kitchen
know.
without,
This
like,
lady, I
stopping
think
and
she
stopping.
lives in Arizona, 92 or 93 years old. She completed a marathon just this weekend, so I thought, wow, that's pretty impressive at that age. So
Yeah, my grandma can't even walk across her kitchen.
some days I can't even walk across the kitchen, Terry. So I was pretty impressed by that. Okay, hey, right here, guys, it says the double histogram shows the distribution of the number of minutes of exercise done by a group of female students and a group of male students during one day. All right, it says compare the distributions using their shapes and appropriate measures and center of variation. Okay. And again, I guess this doesn't really talk about age so much, as much as it talks about the number of minutes down here. So go ahead and put down here, this is the number of minutes that students exercise. I was thinking age, probably because of that news story. Guys, do I have females up top or males on top? Female? Okay, so this is a female, this is the male. Okay? So right here, guys, what I want to talk about then is this. I want to say, well, here's the graph. All right, there's a part to this right here where it starts talking about the following. It says, compare the distribution using their shapes and appropriate measures of center and variation. Guys, how about the shape? If I would get rid of this last one right here, does that graph look pretty centered or symmetric right here? That shape's probably a pretty symmetric, right? Not perfectly symmetric, but pretty close, isn't it? Would you guys agree with that? Okay. So I'm going to say that this is some type of I'll try and squeeze it in here. It's a symmetric shape. All right, that's what they want you to know. Identify shape right here, okay? Identify your shape right there. How about the shape of the male graph? Is there any skewing going on in that one?
Yeah.
What direction?
Left.
Left. It's skewed to the left, right? It's skewed to the... This one's skewed to the left. All right. Guys, a symmetric data set is usually considered a typical data set right here. So when we start talking about variations right here in their shapes, guys, if something's symmetric right here, if something is ever symmetric, this is what I want you to know. Mean and the median are usually pretty good measures of center for that. The mean and the median will usually be pretty good measures of center anytime a graph is symmetric. And then variation again. Variation can be symmetric just like a box and whisker plot can be. So your variations, a good value would be a 5-number summary. If I just put 5-number S up here, use the extremes, the quartiles, and the median again, you'd be in pretty good shape. Okay? Now, for your measure of center and variation for something that's skewed left, this is skewed left, all right, just like the other example was. If it's skewed left, then a good measure of center is going to be the median value. Okay, the median is going to be the number in the middle. So guys, it looks like to me most of the exercising occurs over here, right? And not much exercising is occurring over here on the left. So a graph like this would be box and whisker plot wise like this. So the best measure of center for this is actually going to come right in the middle, or the median. Okay, because your average is going to be somewhere in the middle. Your median is going to be your best center of measure. So best center of measure would be median. And anytime we talk about variation again, anytime we talk about variation, what are the ranges? How does this vary? How does it change? Well, again, 5-number summary. We're relating all of these histograms right here to box and whisker plot. That's all you're doing. That's all you're doing. Okay? So if they ever ask a question about measure of center, if something is ever symmetric, what two values could work? What two values could work if something's ever symmetric? Mean or median, and anytime we talk about variation with this stuff, relying on that 5-number summary from the last section. If anything's ever skewed, then what number is your best measure of center? What's it say here? Median. Okay? All right. I don't want to spend a ton of time on this. This stuff kind of is what it is. But moving forward here on this next page. Oh, I should back up. Do you guys have all that?
Yeah.
Okay. Again, notes look kind of long, but there's a lot of writing for this. Okay, this is the good one right here. This is an excellent example right here, comparing distributions. This is an excellent example right here. You might want to star example 4. Guys, I thought this was an appropriate example. The table shows, it says the table shows the results of a survey that asked men and women how many pairs of shoes they own. Girls, you're crazy about shoes, right? Is that true? Most of us? Sometimes? How about, are there any guys in here that are crazy about shoes? I am. Am I the only one? Oh gosh, I guess I was born north of Highway 3 or something like that, huh? Ease down, killer. All right, here we go. What I want to do is this, guys. We're going to make a table that shows how many pairs of shoes each person owns. And what we're going to do is we're going to do this in a box and whisker plot. We're going to make a double box and whisker plot that represents the data in each shape. So, guys, what's listed first here, men or women? Okay, how many men did we survey? Okay, I'm telling you right here, the minimum is what value? 4. So, of the 30 guys that were surveyed, the minimum number of pairs of shoes that one person may have owned in that was 4. Okay? What was the maximum number of pairs that they owned? 30. Okay, and then in this data set, what was the first quartile? Median was 15, and the third quartile was 25. Average number of pairs of shoes that those guys had, what was the number here? 16. Seems a little high to me. Okay? And then they talk about this standard deviation. Standard deviation was what value? 10. It means that the typical number would vary from the average by about 10. So a typical number would be from, what's 16 minus 10? 6. And what's 16 plus 10? So most men usually have somewhere from 6 to 26 pairs of shoes based on this table. Okay? Let's go ahead and make the men's box and whisker plot here, guys. We'll compare this. Guys, what was the lower extreme, or the minimum value, if you will, for men? What was the minimum value here, guys? 4. This is my lower extreme right here, isn't it? So I'm going to plot 4 here for men. How about the first quartile? I'm sorry. What was the maximum for men? I should back up. I missed that. 30. So the upper extreme, we're going to plot 30. So that's right, boy, it's right here. Can you guys, is that showing up okay on your paper? Okay, so plot the extremes. Then it said we had a first quartile value of what? 8. So this is like your lower quartile, which was 8. Median was what value here? 15. And then finally the third quartile, or the upper quartile, was 25. So I'm going to go ahead and just plot this. I'll put a box around the quartiles. So there's that box right there. And I'll highlight my whiskers. Guys, how about the shape of that? Is that skewed one way or the other, or is that pretty symmetric? Length of the whiskers about the same, or are they different? About the same, so that'd be a symmetric, pretty symmetric graph right there, right? Pretty symmetric there. What's that? Between the quartiles. So the quartiles were, see, the first quartile was 8, right? And the third quartile was 25. Yep. And maybe I should have done that in the opposite order. Maybe I should have put the 2 whiskers on from left to right first, and then put the box in between the whiskers. I'll do that on the next one. Let's compare this to the women right here. Guys, what was the lowest number? What was the lowest number of pairs of shoes of these 25 women? What was the lowest number of pairs for women here, guys? 8. Okay, so I'm just going to plot these values for box and whisker plot. I need the minimum, maximum, I need the quartiles, and I need the median right here. So I'm going to plot these 5 values here. And we'll leave the mean and the standard deviation out, as we're going to look at that in a different setting here. But right here, I'm going to plot 8 and 35 for my extremes. Uh, 12 and 23 are my quartiles. And it looks like 15 is the median. Okay. So I've got all 5 of those plotted right here. I'm going to do my whiskers on the end, so the left whisker. Hey guys, when I do the whiskers right here, how about the skewing on this? What direction is this going to be skewed automatically? Skewed to the left. Right, yep.
No.
Somebody is pulling this data up. Somebody has way too many shoes is what this is saying. Kind of like my wife.
What's the last number?
35, that's the maximum right here. Okay. So you're plotting these values right here on that second one right here for your females or for your women. And then the box is going to go right here. So, guys, we would expect women to probably own more pairs of shoes than men. Would you guys agree with that? Is that, would most people agree with that statement? Most women probably own more pairs of shoes than women. Look at your lower extremes right here. Who has more shoes on the lower extreme end right here? Women. Okay. Is the middle 50% closer together or further spread out here than the men? That middle half is closer together, even though the median is here. So let's just pushing this to the right. When I say this something is skewed to the right like this, then basically they're saying, you know what? We're moving this data to the right, which is a higher value. So based on this plot right here, guys, would you say women or men typically own more pairs of shoes? What would you say here? Women, because values are skewed to the what? Right, okay, and the way it compares, well, 4 was the lowest one here, 8 was the lowest one here, so it makes sense. The medians are about the same. The lower quartile here is higher, the upper quartiles are about the same, but the upper extreme is higher for women. So on this right here, compare the number of pairs of shoes owned by men to the number of pairs of shoes owned by women. You would say, charts show
What's in the office?
charts show that women typically own typically own more pairs of shoes?
I don't even care.
Okay. So there's that right there. Chart shows that the women typically own more pairs of shoes. Are we okay with that? All right. So I guess the last question I need to ask here, and this is going to be very new for you guys, we also had in this chart the mean and the standard deviation. How far away from the average is a typical number? So for men right here, the average pair of shoes that a man owns was 16 with a standard deviation of 10. Meaning if you wavered 10 above or 10 below, you're kind of within that typical amount. For women, what was the average? 18, and its standard deviation was 8, meaning that if you have 18 pairs of shoes plus or minus a value of 8, so what would 18 minus 8 equal? 10, or 18 plus 8 would be 26, right? Most women typically have between 10 and 26 pairs of shoes. Okay? Karen, how many pairs of shoes do you own? Ballpark. Or you think you're between 10 and 26? Probably. Okay, probably. So this is where this gets interesting right here, guys. This is something that's very new for you guys right here, this chart. This chart, pretty important right here. What I want you to do, though, is this. You know, I'm going to leave it like this. Change this chart right here to, I'm going to leave it. I'm going to leave it. The question says here, about how many of the men surveyed would you expect to own between 6 and what, guys? Okay, here's the deal. Go back to that chart right there. The mean for men's pair of shoes was, I'm going to write them down here. The mean was 16 and the standard deviation was 10. All right? So, here's the deal. On a standard deviation chart or something like this, a symmetric chart right here, standard deviation charts start looking at something like this. And I just want you to get the very basics off of this. They're saying the average score right here is the what? Mean or the median. And it says if you go one standard deviation away, what percent of the numbers, what percent of these values right here, what I guess I'm really looking at are these values, what percent of the values lie to the right of the average? What percent does that say right here, guys? And what percent lies to the, what percent lies to the left? Another 34%, right? Okay, see that in that chart? So here's the deal. When they start asking you questions about percentages like this in the standard deviation chart, you're going to want to refer to this chart right here. Here's how you answer this question. Guys, the average rate here for men, number of pairs of shoes they own, how many?
16.
With a standard deviation of what? 10. This means what percent own from 16 plus or minus 10 shoes? What did you say 16 minus 10 was again? 6. What did you say 16 plus 10 was again?
6.
Notice the question right here. It says how many people own between 6 and what? Okay, here's the deal. Going 10 units above or one standard deviation above, isn't one standard deviation a value of 10? Isn't one standard deviation a value of 10 here? If I go, notice what this says here, one standard deviation to the right or 10 to the right, what percent are going to be away from the average there? What percent away from the average are you there, guys? What is it? What's that percent right here? And we also went 10 below, or we went one standard deviation below the average, right? So from 6 to 26, what's 34% plus 34%? It is what value? Okay, now I'm concerned. I don't think many people were listening to this right here, but this chart right here basically is saying if I go one standard deviation to the right, 34% of the values are going to lie. I should say 34% of the values will be within one standard deviation of the mean. Okay? How about if I went 2 standard deviations to the right? You would have 34%, and how much more would you add to that? 13.6, all right? So there'll be some questions about that stuff, and we'll look at that probably tomorrow when you get some time to work on some things, but everybody get everything down in their notes, first of all. Everybody have that there? Okay. Do not forget to submit 7.2 if you haven't done so already, and then anything that you got on Friday during class to work on, make sure I have that before you leave.
Mr. Person,
Yeah.
I'll have my binder at my house, so can I turn in my puzzle and everything tomorrow morning?
Yeah. Yep. All right.